Hello student, today we are going to discuss some MCQ type question on calculus. Okay, so first question, solve modulus of 4x plus 1 less than 9. Less than 9. Okay, all of you know that if mod of x is less than a and if a is greater than 0, then this inequality can be solved as minus a less than x less than a. Now here 9 is greater than 0, so we can write this as minus 9 less than or equal to 4x plus 1 less than 9. Then subtract 1 from all sides. So minus 9 minus 1 is less than 4x less than 9 minus 1. So this can be written as minus 10 less than 4x is less than 8. Now divide both sides by 4. So it is minus 10 divided by 4 is less than x less than 8 divided by 4. Since 4 is a positive number, there is no need to change inequality sign. So this is equal to minus 5 by 2 less than x less than 8 by 4 is what 2. So what is the solution of this inequality? It is what minus 5 by 2 to 2. It is open interval. If it is less than or equal to 9, then this will become less than or equal to less than or equal to less than or equal to, this becomes less than or equal to, and your answer will be minus 5 by 2 less than 2. Okay. Now second example, same example, if there is a no modulus absolute value function that is only plain, suppose it is solve 4x plus 1 is less than 9. Solve this equation. 4x plus 1 less than 9. Then again, this can be written as 4x plus 1 minus 1 less than 9 minus 1. So this is equal to 4x less than 8 divided by 4. So it is x less than 8 divided by 4. So this is what x less than 2 means. What is your answer? Minus infinity to 2. Okay. So what is the solution of this set? It is the solution of the set is x belongs to from minus infinity to 2. Again, if there is less than or equal to sign, then what is the solution here? It is minus infinity to plus 2. Closed interval. All of you know that. What is a closed interval? If there is an open interval means a less than x less than b, and if there is a closed interval, its meaning is a less than or equal to x less than or equal to b. So what is the solution of this inequality? The solution of this inequality, x, if it is less than, then open interval minus infinity 2, because it is less than 2. Less than 2 means what? Okay, this is a real line, here is the 0, here is the 2. So all x which are less than 2, so it is what? Minus infinity to 2. Okay, but if it is a less than or equal to, then it is minus infinity to plus 2. So now take one more example. Suppose, what is the solution of this inequality? Twice x plus 3 less than or equal to 15. Again, since 15 is a positive number and it is less than or equal to, it is minus 15 less than or equal to twice x plus 3 less than or equal to 15. You can remove this modulus sign by using these properties. That is, if mod of x is less than a, then minus a less than or equal to x less than or equal to a. So again this is equal to minus 15 minus 3 less than or equal to twice x less than or equal to 15 minus 3. So this is equal to minus 18 less than or equal to twice x less than or equal to 12. So if you divide by 2, then it is minus 9 less than or equal to x less than or equal to 6. So what is the solution of this inequality? It is all x belongs to minus 9 to 6, closed interval. Okay, now next example. Solve 5x plus 3 less than or equal to 17. Less than or equal to 17. Okay, this is equal to what? 5x less than or equal to 17 minus 3. So 5x less than or equal to 14. So x is less than or equal to 14 by 5. So what is the solution? It is minus infinity to 14 by 5. This is the solution. All x belongs to minus infinity to 14 by 5. Then that x satisfies this inequality. Now take one more example. Now find k belongs to n such that 1 upon n minus 0 is less than 0.2. What to determine what is the n for n greater than or equal to k. So what to determine आपल्याला अशी k ची व्हॅल्यू फाइंड करायची की सिक्वेन्स आणि लिमिटचा डिस्टन्स हे लेस दॅन एप्सिलॉन. एप्सिलॉन is what 0.2 if we choose all n which is greater than or equal to k. So all of you know that 1 by n minus 0 is what 1 by n, and since it is a positive number, since 1 by n is greater than or equal to 0, there is no need to write modulus sign. So 1 upon n less than 0.2. So what this implies, n is greater than 1 upon 0.2. If we change if we take this term on the numerator and this term on the denominator, this sign become less than become greater than. Okay, but what is 1 upon 0.2? This implies n is greater than 10 divided by 2. Means what? N is greater than 5. So what is our k? K must be 6. If our k is equal to 6, then 1 upon n minus 0 is less than 0.2 for all n greater than or equal to k. So what is the answer? K is equal to 6. Now next check whether xn equal to 5 by 3 raised to n is convergent or divergent, and if it is convergent, find its limit. Now all of you know that the sequence xn is equal to r raised to n is convergent if our r is lie between 0 and 1. If it is lie between 0 and 1, if it is greater than 1, then sequence is what? Divergent. Now 5 by 3 is what? 5 by 3 is equal to 1.66. So it is greater than 1. This 5 by 3 is greater than 1, and therefore the answer is what? It is divergent sequence. It is divergent sequence, and its limit is what? Infinity. Its limit is what? Infinity. If you take limit n tends to infinity, this sequence is what? Is equal to, value of this limit is equal to infinity. Now similarly, if you take xn is equal to 3 by 5 raised to n, then all of you know that this 3 by 5 is less than 1, and therefore this sequence is what? Convergent. This sequence is convergent, and we know that if it is less than, if xn is equal to r raised to n is the given sequence, and if our r is lie between 0 and 1, if our r lie between 0 and 1, then limit n tends to infinity, r raised to n is equal to 0. So here this 3 by 5 is less than 1, and therefore limit n tends to infinity, 3 by 5 raised to n is equal to what? 0. Therefore this sequence is convergent, and its converges to what? 0. But this sequence is divergent and diverges to infinity, because 5 by 3 is greater than 1, but this 3 by 5 is less than 1. Now next the sequence xn is equal to 1 upon n plus 1 plus 1 upon n plus 2 plus dot 1 upon n plus n is increasing or decreasing. We want to check whether it is increasing or decreasing sequence. We want to check whether this sequence is increasing or decreasing sequence. So when we say a sequence is increasing sequence, if xn plus 1 is greater than or equal to xn, then we can say that the sequence is increasing sequence. If it is greater than only, then it is strictly increasing. And if xn plus 1 is less than xn, then it is decreasing sequence. So we are going to check whether it is increasing or decreasing sequence. For that, we are going to determine difference of xn plus 1 and xn. So what is xn plus 1? It is 1 upon n plus 1, 1 upon n plus 2, plus dot dot dot. If we put here n equal to n plus 1, that is twice n plus 2, twice n plus 2, then this can be written as xn plus 1 is equal to 1 upon n plus 1 plus 1 upon n plus 2 dot dot dot. What is the previous term of this sequence? It is 1 upon n plus n, that is twice n, then 1 upon twice n plus 1, then 1 upon twice n plus 2. Okay, and therefore if we take difference of, and what is xn? It is 1 upon n plus 1 plus 1 upon n plus 2 plus dot 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 1 upon n plus n. That is, this is twice n plus 1 twice n plus 2. This is what xn plus 1. So if we take the difference, that is xn plus 1 minus xn, then this term will get cancelled here. Okay, what is left? It is 1 upon twice n plus 1 plus 1 upon twice n plus 2. Since it is a positive number, it is greater than or equal to 0. This is what greater than or equal to 0. What this implies? Xn plus 1 minus xn is greater than or equal to 0. This implies xn plus 1 greater than or equal to xn, and therefore the given sequence is what? Increasing sequence. Increasing sequence. This is what? Increasing sequence. Now next. Next x1 is equal to 2 by 3 and xn plus 1 is equal to 2 minus 1 upon xn. Is it increasing or decreasing sequence? So we know that x1. To check whether it is increasing or decreasing, at least we know the few terms of the given sequence. So what is x2? If we put n equal to 1 here, so x2 is equal to 2 minus 1 upon x1. So it is 2 minus 1 upon 2 by 3. So this is equal to 2 minus 3 by 2. This is equal to 4 minus 3. It is equal to what? 1 by 2. So it is what? x1 is 2 by 3. x2 is 1 by 2. So what is the, if you compare this term, then it is equal to, what is x2? x1, it is 0. If we find its decimal fraction, then 0.66, and what is x2? 0.5. So 0.xx is greater than 0.5, that is x1 is greater than x2, x2 is greater than x3, means what? This sequence is decreasing sequence. This sequence is what? Decreasing sequence. Now next, check whether the sequence xn is equal to 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus dot 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 1 upon n factorial is bounded. Whether this sequence is bounded or not. Whether this sequence is bounded or not. So now, when we say a sequence is bounded, if it has an upper bound and lower bound. If the given sequence is upper and lower bound, then we can say that the sequence is what? Bounded sequence. Now, if we find determine few terms of this sequence, then we will get what is first term? x1 is 1, x2 is 2, okay, x3 is what? 1 plus 1 upon 1 factorial plus 1 upon 2 factorial. So if you observe, all these sequences are greater than or equal to 1. So 1 is a lower bound. 1 is greater than or equal to xn. All these terms are greater than or equal to xn. Or if you okay, so 1 less than or equal to xn. Now next 1 is the lower bound of the sequence. Next, all of we know that if we write this as 1 upon 2 factorial is equal to 1 upon 2, then what is 1 upon 3 factorial? 1 upon 3 factorial is equal to 1 into 3 into 2, but again 1 by 3 is less than 1 by 2. 1 by 3 is less than 1 by 2, so this is less than 1 upon 2 into 2, which is equal to 1 upon 2 raised to 2. Similarly, 1 upon 4 factorial is less than is equal to 1 upon 4 into 3 into 2, which is less than or equal to 1 upon 2 into 2 into 2, because 1 by 4 is less than 1 by 2, 1 by 3 is less than 1 by 2, and therefore this 1 by 4 is less than 1 by 2, 1 by 3 is less than 1 by 2, so it is less than, it is equal to 1 upon 2 raised to 3. So 1 upon 4 factorial is less than 1 upon 2 raised to 3. Similarly, 1 upon 5 factorial is less than 1 upon 2 raised to 4, and so on. Therefore 1 upon n factorial is less than 1 upon 2 raised to n minus 1. So if you observe all these terms, 1 upon 1 factorial up to, okay, but all these terms up to this can be written as, this is equal to 1 plus 1 plus this 1 upon 2 factorial is equal to 1 by 2 plus 1 upon 2 square plus 1 upon 2 cube plus dot 1 upon 2 raised to n minus 1. All these sequence are less than or equal to. We can write this as, this is equal to 1 plus 1 plus this is equal to 1 by 2 plus 1 upon 2 square plus 1 upon 2 cube plus dot 1 upon 2 raised to n minus 1. We are writing this 1 also here, 1 plus 1 by 2. Okay, so what is the first term? This is a geometric series. Having first term is 1 and common ratio is 1 by 2. Common ratio is what? 1 by 2. This is a geometric series. Also, what is its sum? Its sum is 1 minus 1 by 2 divided by 1 by 2 raised to n divided by 1 minus 1 by 2. Okay, so now as limit n tends to infinity, this term becomes 0. So it is 1 divided by 1 minus 1 by 2. So it is 2 minus 1. So it is 1 divided by 1 by 2. So it is equal to 2. So what is the sum of this sequence? Sum of this series. Sum of this series is 2. Sum of this series is 2. So 1 plus 2 is what? 3. So this sequence has upper bound 3 and lower bound is 1. Okay, so hope you understand this sequence is bounded. Having upper bound is 1 to 3 and lower bound is what? 1.